Hello everyone. Class has started, so no more phones, please. So if you have your exam 1, you can see what mistake you made in the exam 1, not exam 1, sorry, exam 2. What mistake you made, and you can fix yourself because you're going to see this again tomorrow. Not the same thing, but similar things. The first row is based on the rules of 0. There is one rule I said, anything that is not 0. Anything not 0. Could be positive, could be negative, could be number, could be variable, anything. As long as it's not 0, and if you raise it to the power 0, what's the answer? 1. And when you have 0 to the 0, only that time you get something doesn't exist. So 0 has only these two rules. Anything not 0, if you have on the power, on the base and power is the 0, answer is 1. As long as it's not 0, because 0 to the 0 doesn't exist. That means 2 to the 0. What is 2 to the 0? 1. What is negative 7x whole thing to the 0? 1. What is 1 to the 0? 1. What is negative 2 to the 0? 1. So see, as long as you have not 0 on the base, the answer is always 1. The problem comes when you have 0 to the 0. What is 0 to the 0? Doesn't exist. So there is only one thing where we have doesn't exist with the power 0. Huh? If you ask for, this will be in the exam tomorrow, right? Yeah. That's why I'm going over them. Now the next rule is for 0 base. So when your base is 0, there are 3 scenarios. Either 0 has some negative number, or 0 has some positive number, or 0 has 0. We already know 0 to the 0 doesn't exist, so we can disregard that. Now 0 with any negative number, any negative power, what's the answer? Remember, negative means it's a fraction. So if you have 0 to the negative 1, it means 1 over 0. And do you know what is 1 over 0? It doesn't exist because we don't have to divide by 0. In other words, 0 cannot have any negative power. Only when 0 has positive power, the answer is 0. Any negative power, the answer doesn't exist. Any negative fraction, the answer doesn't exist. Any negative whole number, the fraction doesn't exist. The answer doesn't exist. But 0 is positive, could be anything. 0 squared, 0 to the 1/2, 0 to the million, 0 to the 1,000, anything. As long as it's a positive number, 0 with any positive power is always 0. So, what is 0 to the negative 1? It doesn't exist because it's a fraction. When 0 is a fraction, it doesn't exist. What is 0 to the 11 power? 0. 0 to the 1/2 power? Still 0. As long as the power is positive, it doesn't matter what do you have, the answer is always 0. Okay. Next comes the rules for 1. Now 1 is a very nice number. 1 to the anything. It could be positive, it could be negative, it could be 0. It doesn't matter. 1 to the anything is what? 1. So 1 is the nicest number in this world. You can put anything on the power, the answer is always 1. So that tells us what is 1 to the negative 1/2? 1. What is 1 to the 6? Still 1. And what is 1 to the 0? Still 1. So 1 can have anything. It doesn't matter what do you have. Positive, negative, zero, fraction, whole number. It doesn't care. Mustafa. Mustafa, your exam. And then lastly, we have the rules for -1. Now, -1 has two things. Either the power is odd or the power is even. Bless you. And odd, it doesn't have to be whole number odd. It can be fraction odd. Okay? As long as it's odd. Like, for example, either power 3 or cubic power, it doesn't matter. Either power 5 or fifth root, it doesn't matter. As long as your number is odd, it's always what? -1. And then for even, there are two scenarios actually. If you have, I forgot to tell you that before. If you have even whole number, and if you have -1 to the even fraction, there are two scenarios. If you have even whole number, for example, 2, what is -1 square? 1. What is -1 to the power 4? 1. What is -1 to the power 100? Still 1. So if you have an even whole number, your answer is always 1. Always. On the other hand, if you have an even fraction, for example, -1 is the 1/2 power. 1/2 means square root, right? So what is -1 to the square root? It doesn't exist because it's imaginary. So if -1 is an even fraction, the answer doesn't exist. But if the -1 has an even power, even whole number, the answer is always +1. So anytime you forget your rules, work with some example and see what really they have. Do they exist? Is it positive? Is it negative? Or is it something doesn't exist? So that tells us what is -1 to the 7th power. 7 is odd or even? It's odd, so the answer is -1. What is -1 to the 10th power? +1, because 10 is an even number, even whole number. So any even whole number gives you 1 back. Any odd whole number gives, odd whole number or fraction doesn't matter. Anything odd gives you -1 back. So I'm going to actually give you this. What happens when you have negative even fraction? And what happens when you have negative even whole number? Or what happens when you have negative odd whole number and negative odd fraction? Okay. So these are the rules for 0, 1, -1, and the rest are exponent rules for Jannah's case. When you multiply the bases, do you add or multiply the powers? Like x squared times x to the 5? We add them. But when you have two powers together, do you add or multiply? Multiply. So many people actually mix those up and you got both of them wrong. Almost all of you got the next one correct. You have more elements on the base, but only one power. So it distributes the power. X to the 5, y to the 5. Same thing if you have a division, it doesn't matter. It just distributes your power. Whether you multiply on the base or you have division on the base, you always distribute the power if you only one power. And then the negative power is the same thing. It just flips your fraction. So y to the 5 divided by x to the 5. And then for division, you have two scenarios. Either the numerator is bigger or the denominator is bigger. So the first one is x squared divided by x to the 5. Denominator is bigger, so what's the answer? 1 over, you subtract your powers, so you get 3. So it's a fraction x cubed. But if you have x to the 5 over x squared, it's a whole, 5 is in the numerator, so it's a whole number x cubed. If the denominator is bigger, you get a fraction. If the numerator is bigger, you get a whole number. Negative power, negative means always fraction. That's why 0 to the negative doesn't exist, because it makes it fraction. So a to the negative 1 means 1 over a. A to the negative 2 means 1 over a is put to the positive 2. A to the negative m means 1 over a to the positive m. A to the negative 4/5, it doesn't matter positive, negative, whole number, or anything. As long as you have a negative power, it always becomes fraction. That means 2 to the negative 3 is also 1 over 2 cubed. And you have to write it as 1 over 8 because I said simplify. That's why I didn't give you anything big, because all these numbers are smaller. So you should go all the way to the final answer. And then comes radical. Radical has two things. Either we have a three things. Either we have a square root, which you always see, or we have any other type of radical like fifth root, sixth root, third root, anything. And then the third scenario is we have a radical and exponent at the same time. So square root is easy. All you have to do is convert this into 1/2 power. So it's not 1 over y square, it's y to the 1/2 power. So you have to write 1/2 little bit on your right side as a superscript, not as a fraction, 1 over y squared. So many people made those mistakes, like they thought this and this are the same thing. So they wrote it as 1 over y squared, and this is wrong. It's y to the a little bit side on his head, 1/2. So you have to be careful how do you write them. The next one is y to the 1/nth. So 1 over n radical. And when you have a power and radical at the same time, power has priority, so it gets on the numerator, and any type of radical becomes a denominator. It's y to the m over n. And then we have scenarios with negatives and fraction power. So negative 3 square means you're multiplying negative 3 times negative 3. We get 9. On the other hand, negative and then 3 square, it means you're multiplying negative and then 3 times 3. So this time the answer is not positive 9, it's negative 9. Because this negative is multiplying, where the first one wasn't multiplying, it was the base. That's why they have a parenthesis. Now, anytime you have a negative, means fraction. So the next one is 1 over 3 to the positive 2. That gives us 1 over 9. The next one is same thing, but this time you're multiplying negative and then 3 to the negative. So it's 1 over 3 squared. So you keep your negative, and then 3 to the negative 2 turns into a fraction. That's how you get 1 over 9 with the negative in the front. Next one is easy. This is square root of 4. That gives us 2. The next one is a negative power, not positive. So you have to write 1 over square root of 4. That gives us 1/2. It's the same thing. It's 2, but 1 is a whole number, 1 is a fraction, because 1 has a negative, 1 doesn't. Now, when you have a negative in the front, it's always a multiplication. So it's negative times square root of 4. That's why you have negative 2. And lastly, your base is negative. The square root of negative 4. And see the rule? When you have a negative base and even fraction power, the answer doesn't exist. So this one doesn't exist because it becomes imaginary number. Well, now it doesn't exist. For your next exam, you have to convert this into imaginary numbers. Not this exam, next, exam 4. Same? Any question? I think only one person in this class got everything correct. And then nobody got everything correct. Everybody has at least one wrong. Some has almost everything wrong. Got 4 points or 5 points. These were easy ones. Any question? So from here, I'm going to give this type of question again. Because this is the final exam question. And most of you got this wrong. Most of you, almost 95%. So step 1, you distribute. We get 2 to the negative 3, x squared to the negative 3, 6 with the 2, x to the negative 3 with the 2. And then many people thought 2 with the negative 3 power is negative 8, which is completely wrong. It's not negative 8. Negative power means it's a fraction, so you have to bring it on the denominator. That's what I said. Don't do anything until you convert your negative into positive, because definitely you're going to make mistake for most cases. So before we play around with negative, anytime you see more powers with the same base, first apply a power rule on that. So 2 to the negative 3, keep it. X to the, what do you have? Negative 6. Many people wrote x to the negative 1. You're not supposed to add them, you're supposed to multiply. Now 6 is a positive power, so we don't have any problem. We can write 36 here because it's positive power. You can simplify. And now, what power we have on the denominator? Again, negative 6. So this question was actually very easy. You see the exact same thing, x to the negative 6, x to the negative 6. So you don't even have to bother converting them into positive. As long as you have the exact same thing, they cancel out. Okay? But if you did convert them into positive, no problem. But you don't have to. So you're left with 2 to the negative 3 over 36. And now we have only one problem, the negative power on the numerator. So we must bring this on the denominator. And we get 36 times 2 to the positive 3. Then what goes on the top? 1. Many people forgot that. Many people. They got the answer correct, but they forgot that there's a 1 on the top. So they gave me the answer as a whole number. But the answer is not a whole number, it's a fraction. So we get 1 over 36 times 8, and that gives you 1 over 188 or something like that. 288, 288. So if you observe, if you made a mistake, you wrote the answer only 288. So you lost points. Expect to see this again tomorrow. Not the exact question, but similar. Any question? Now you're going to go over the third page, factoring. So tomorrow you have many factorings to do. There will be 2 questions from 2 terms, 2 questions from 3 terms, 2 questions from 4 terms. Actually, no, 1 question with 4 terms and 1 or 2 questions with the 4th power. So we have addition, sum of 2 squares. We have no idea what that is, so we call them prime. Now the 2 terms have 2 choices. Either, not choices, 2 possibilities. Either we can pull out a GCF or it's a difference of perfect squares. So in B, even the first one is a perfect square, but the second one is not. Second one is 16x. So you have to factor out your x and you get x minus 16. And now this is not perfect square anymore, so we cannot go any further, we stop. However, C is 2 perfect squares. It's a squared minus b squared. So it's difference of perfect squares. That means you observe your bases. The 2 bases we have here is a and b. So you add them and you subtract them. That's all you have to do. Same thing, C is not a perfect square, difference of perfect square. So you factor out. And you are done. But E is a perfect square because 25 is 5 square. So you see your bases are x and 5. So you add them, x plus 5, and you subtract them, x minus 5. The next one, it's not perfect square yet because we have a cubic function. And you see GCF x in both terms. So first step, you factor out a GCF and you get x squared minus 49. And then many people stop. Why you cannot stop if you still have something that is factorable? X squared minus 49 is the difference of perfect squares because 49 is 7 squared. So this term is actually x squared minus 7 squared. So we have bases x and 7. So you have to go one more step. Your GCF and then the difference of perfect squares. The next one was interesting. Many people thought the 2 factors are 30 and 1. Why did you think that? We are looking for 2 numbers, multiply to 30, but it has to combine to the middle term. Our middle term is 1. Definitely when you combine 30 and 1, you don't get 1, you get either 29 or 31. Then why did you think the answer is 30 and 1? It doesn't make sense. Since 30 and 1 not going to work, which two will be working here? 6 and 5. So x6, x5. 6 is the bigger one. It has to get the middle sign. And then to get 1 from 6, we have to add the 5. Okay? It's 5 and 6, not 1 and 30. This one is same thing. 2 numbers multiply to 30, combine to 11. You already have them in front of you. It's 6 and 5. So x6, x5. The difference between the left and right is that you still have to have your 6 negative, but this time you want to get 11 from the 6. So you need to have the same thing, same sign for 5, what you have here, because you have to add them. So if you want to add them, negative 6, you can only add them if your 5 is negative. So negative 6 minus 5 gives you negative 11, and negative 6 times negative 5 give you positive 30. So when you add two things, you have the same sign, but when you want to subtract something, you have two different signs. They are very similar. Let's do this one first. Two numbers multiplied to 6 combined to 5. Many people thought it was 6 and 1. 6 and 1 doesn't work. Because if you want to put 6 and 1, its x has to be negative and your 1 has to be positive. But if you multiply them, your answer is negative 6. But we want the product to be positive 6, not negative. So 6 and 1 doesn't work. Even though the sum works, but the multiplication doesn't work. Since we cannot use 6 and 1, so what is our hope? 3 and 2. And we want to add 3, 2 to get the 5, right? That means we have to have the same sign. Negative and negative. So it was easy question, but many people messed that up. And now comes the interesting one. Like I said before, anytime they ask you to factor, the first step always should be GCF. If you have any GCF, factor that out. So do you have any GCF on I, in I? X cube, right? We take the smallest power. It's not X, it's X with the 3 power because 3 is the smallest power here. So when you factor out to x cubed, you get x squared minus 3x minus 28. And then many of you stopped. You cannot stop because this is actually more factorable. Which two numbers multiply to 28 combined to 3? You need to know your timetable. Which two numbers, Mustafa? 7 and 4. That means you have to subtract them. So they're going to have opposite sign. 7 has to have the middle sign. It's a must. That means 4 has to have positive sign. See, it is factorable. Just because you didn't know your timetable, many people say it's prime and lost 2 points because 2 points for 2 factors. And then the last one, many of you arrange them in decreasing power order, but you didn't have to do that because you're going to get the same results anyway by keeping them. But before you even do anything, you always should look for GCF. Do we have any GCF here? X. So factor out your GCF. We get 5x squared plus 6 minus 10x cubed minus 12x. How many terms we have? 4. So how do you factor 4 terms? Grouping. So in the first group, what do you see in the first group? Nothing, right? That means we have invisible 1. So we factor out the invisible 1 and we get 5x squared plus 6. But what do you see in the second group? X. How about the numbers? Between 10 and 12, can you divide 10 and 12 by the same number? 2. And how is the second group started with? A positive sign or with a negative sign? Negative, right? Would you like to start your day with something negative? Same thing, polynomial doesn't want to start its day with negative. So it wants to take out negative also as a common factor. Now, when you factor negative 2x out, what do you have from negative 10x cubed? 5x squared. And you have negative 12x, you factor out negative 2x. What is left? Plus 6. In order to figure out what is left after factoring out, you can always do division manually. Negative 12x minus 2x. X cancel out, negative cancel out. 2 goes to 12 6 times, so we have plus 6. Now, what do you notice in both groups? 5x squared plus 6. So you factor that out. And what is left in the first group? 1. And the second group, 2x. But you cannot forget to use GCF. So you also have to bring your GCF down. And that's how you have 3 terms for this polynomial. Then we have fourth degree. Huh? So you still have 2 groups. Group 1, group 2. What do you notice in both groups? What do you have in both groups? I wrote it in green. Don't you have the same green in both groups? Yeah. So you factor that out. That means what is left in the first group? If you factor out 5x squared plus 6, what do you have in the first group? Just 1. That's why I wrote it in red. And what do you have in the second group? After you factor out 5x squared plus 6. Negative 2x. So you put them together. See, for your convenience, I have the groups in same color, and whatever remains, it's same color. So you can see when you factor out, whatever remains, they go together in one group. Now, fourth degree. A squared, a to the 4 minus b to the 4, our goal is to our goal is to rewrite these into 2 perfect squares. Because when you have 2 perfect squares, only then we can factor them. So we rewrite the fourth power into a square with a square and b square with a square. We need to do that because we want to see what base we have if we convert this into difference of perfect squares. And that gives us the first 2 factors. A square plus b square, a square minus b square. Now, a square plus b square, it doesn't have any negative, so it's prime. We cannot factor that anymore. But this is difference of perfect squares. So that means we can factor this more. So we do a plus b, a minus b. That gives us our final product as a square plus b square, which is prime. And then the 2 factors from a squared minus b squared. Oops. So fourth power, this one has 3 factors. The next one is fourth power, but this time we say a trinomial. So we look for 2 numbers multiplied to 24 combined to 2. Which 2 numbers multiplied to 24 combined to 2? 6 and 4. decide their sign. Which one is positive, which one is negative? 6 has to be positive because the middle sign. That means 4 has to be negative. And then I found a common mistake. People thought this is x. But this cannot be x. Why not? Because if you multiply them, you get x times x, x squared. But we don't have x squared the first term, we have x to the 4. So instead of x, what do you supposed to have? X squared. And then you lost points because you thought you would stop here, which you cannot. X squared minus 4 is difference of two perfect squares. So it's x squared minus 2 squared. As long as you have two perfect squares and a minus between them, you always have to keep factoring. So that gives us x plus 2 and x minus 2. But you cannot forget about your prime, x squared plus 6. And now it's fully factored. So expect to see one of these tomorrow. One of the four term, and then so we have two terms, GCF and perfect square. So one GCF, one perfect square. Then we have three terms. Actually, let me tell you here. Search. So two terms. Two terms have two choices. Either it's GCF or perfect square, difference of perfect squares. So one from here, one from there. When you have three terms, you have either direct factoring, or you have AC, and you have trial and guess. So 1, 1, 1. I'll give you three questions from three terms. Then you have four terms. Four terms has GCF and then grouping. So 1, 1, or probably combining one like the one we had here. One or the grouping and GCF. And then we have fourth power. Fourth power. So fourth power has two choices, either something to the 4 minus something to the 4, or it's x to the 4 and then x squared and then a number. So 1 and 1. So 1, 2, 3, 4, 5, 6, 7, 8. 8 factoring. 8 factoring, and your chart probably not going to be 35, but at least 30 from the chart. At least 30, and you have, let me count again, I forgot, 1, 2, 3, 4, 5, 6, 7, 8. 8 factoring questions, at least 30 exponent rules. These are from chapter 6. Plus, there are more. I'm not in search. Okay. Now, if you look at the review sheet has two things extra. One is the application. So there will be one application and one solving. So there will be one solving problem. And these are chapter 6. All of these are chapter 6. So the 8 factoring plus one application and one solving. And the application will be similar to this one. Okay. Like probably the same question, the function is different. for solving one of them. Let me try the middle one. Middle one is AC method. So let me refresh your memory with the AC method. AC method says you multiply A and C. So we have 5 times -21. And then it becomes bigger if you multiply them. So instead of multiplying, you can just make them smaller. 5 is 1, 5. 21 is 3, 7. So you break them down into prime factorization and see which two gives you the result 32. For example, 3 times 5 is 15 and 7. We don't get 32 from here. So you multiply the other way around. We multiply 1 with the 3, we get 3, and 5 with the 7, we get 35, and yeah, we get 32 from here. So 35 and 3, we have -35 and +3. That gives us -32. We do this when you get bigger number in the product, when you multiply AC. But when you have something smaller, like for example, if you have 2 and 21, it's smaller, it's 42. So 42 has either two choices, not two choices, few choices. So you play with the choices and see which one gives you the middle term. So we have 5x squared minus 21, and instead of 32, you rewrite that using -35x and +3x. So -35x plus 3x gives you -32x. And then you have 4 terms, so you do grouping. So you see 5 and x in the first group, you have x minus 7. Then in the second group, you have +3, you get x minus 7. Then again in both groups, you see the same thing, x minus 7. So you factor that out, and you get 5x plus 3. When you have their product to be 0, that means each of them to be 0. Either the first one 0, that gives us 7, or 5x plus 3, 0, and then you subtract 3. 5x is -3, you divide by 5, so you get x is -35. So first you factor, either it's direct factorable, or it is AC method, or it is trial and guess method. So use any method to factor. Once you have your factors ready, then you set them equal to 0, solve. So that's the difference between factoring and solving. In factoring, once you factor, Muhammad, in factoring, when you factor, you're done. But when the direction says solve for x, it means once you factor, you have to set each factor equals 0 and then get the x alone. Question? For application, it says we have a ball throwing down what time the ball hits the ground. And the function they gave us is for the height. So all you have to do is set your function -5t squared plus 20t plus 25. Set this equals 0 because your height is 0 when the ball hits the ground. We went over this in details during that lecture, 6.7. So if you don't remember, go back to the lecture. I'm just rushing through here. Then you observe all of these are divisible by 5. So I divide everything by -5. because our polynomial starts with a negative. I don't want it to start with something negative. So I get t squared minus 4t minus 5 equals 0. And then you just solve. So you factor, you get minus 5 plus 1 is set each factor equals 0 and solve for t. T is time and time cannot be negative. So you have to disregard anything that doesn't make sense in real life because this is a real life application. Any question? Now trial and error. I'll do only one. What's this one? Are you guys done? Or any time? None? So for trial and error, anything is fine. What's this one? We're going to use trial and error because of two reasons. One is if you multiply 18 and 35, you get something big and you have no idea what to do with the big numbers. Plus, we are given the options. So because of these two reasons, we're going to use trial and error. Trial and error or trial and guess. It means we're going to split the first and last term based on the multiple choices they give us. So we have 3, 3, 6. That means 18 is 3x and 6x. 35, we look at the last term, 5 and 7 and 5. So it's going to be 5 and 7. And then you just play around to see which pair gives you 27. So if you connect this and this, do you get 27? 6 and 5 gives us 30x. 3 and 7 gives us 21x. Do you get 27 from here? No. So my pairing is wrong. So let me repair them. 3 with 5, 6 with 7. 3 with 5 gives us 15x. 6 and 7 gives us 42x. Can we get 27x from there? 42 has to be positive because you're looking for positive 27. That means, let's see what happens when you subtract your 15. So 42 minus 15, 12 minus 5 is 7. 3 minus 1 is 2. Yeah, we do get 27. Then we decide their sign. 42 is positive. By default, the first two are always positive. So this is positive, this is positive. We don't have to change their sign or anything. We look at the signs for the constant term. 42 is positive, that means 7 has to be positive because 6 times 7 gives us 42. We want 15 to be negative, that means 5 has to be negative because 3 cannot be negative, 3 has to be positive. Once you decide their sign and their numbers, then you write them into two parentheses, into two groups. One of them gets 3x, the other gets 6x. And then do you remember how do you pair them? 3x will get 5 or 7, which one? 7 because we didn't multiply 3 and 7. So whatever you didn't multiply, you have to put them together. So we didn't multiply 3 and 7, so 3 and 7 goes together. That means 6 and 5 has to go together. And to make sure whether these are correct or not, you should always can distribute. 3 and 6 gives us 18x squared. 3 and 5 gives us negative 15x. 7 and 6 gives us positive 42x. 7 and 5 gives us negative 35. When you put them together, we have the exact same things as the original function, as the original quantity. So this is for checking. You can check yourself whether you're correct or not. Any question? One. Do you want more? No. So one of these, one solving, one application. And now chapter 7. Chapter 7 will be 3 questions. One is find the domain, one multiply, and one divide. Initially, I wanted to give simplifying, but then I realized when you multiply and divide, you do simplify there. So I don't have to give you an extra simplifying question. The simplification comes automatically with multiplication and division. There will be 3 questions, only 3 questions from chapter 7. Now for domain, only domain. Domain, multiplication, and division. Only 3. For domain, all you have to do is take the denominator and set it not equal 0, because we know our denominator cannot be 0. And then you solve for x. When you solve for x, you need to give me the interval notation. So when you solve for x, it tells you what you cannot plug in for your x, what you cannot substitute your x with. So from the entire number line, you take everything else except that number. When you have one number, you have only one problem. But when you have more numbers, you take out all of these from your number line. So you write down the first interval, negative infinity to the first number you cannot take. Second interval is the first number you cannot take to the second number you cannot take. Then you keep going on for all these intervals and make sure all those numbers, the entire interval will have parentheses. You're not going to have any bracket for your domain. It's always parentheses. And that's all you have to do. Take the denominator, solve for x. Either it could be something easy like that, or it could be something factorable like this. So once you know you're factoring, if you see something, it's easy for you to factor. If it's factorable, go ahead, factor and solve. If it's a single thing, simple, 2 terms, then you just solve. Then multiplying. When you multiply, there are only 3 steps. Factor, cancel, rewrite. That's all you have to do. If it's factorable, you always factor. And then cancel like terms, one from anywhere on the numerator and one from anywhere on the denominator. For example, do I have, I have good examples here. Which one do you think look harder, the left or the right? I'll do only one. Any comments? Any vote for any of these? Right? Great. So we have numerators with 3 terms, means they are factorable this way. 2 numbers multiplied to 35 combined to 2. What are they? 7 and 5. How about the signs? 7 is big, it has to be minus. Then 5 has to be positive. Denominator is similar. 2 numbers multiplied to 15 but combined to 8. 3 and 5. How about their signs? Both positive. Our denominator has 3 terms, so direct factoring. Multiply to 28, combine to 3. 7 and 4. Sign? Negative and positive. But you have 2 terms on the top. So 2 terms have 2 choices. Either it's a GCF or difference of perfect square. Which one? X squared minus 16. Is it a GCF or difference of perfect squares? Perfect squares. That means we are going to get 2 factors. What are the 2 factors? X plus 4 and minus 4. Because our 16 is 4 square. So you take your bases, add them, subtract them. And now you're allowed to cancel anything from the top with the same thing from the bottom. It doesn't matter whether it's on the left or right, doesn't matter. It's top versus bottom, okay? That's all. So we have x minus 7 on the top. Do you see any x minus 7 anywhere on the bottom? On the right. Then you have x plus 5. Do you see any x plus 5 on the bottom anywhere? Here. Then we have x plus 4. Do you see any x plus 4 anywhere on the bottom? Here. And then the last thing is minus 4. Do you have any x minus 4 on the bottom? No. So we rewrite x minus 4. And on the denominator, we left with x plus 3. So this is not cancelable, and also this one. So whatever we could not cancel, we put them together. That's all you have to do. Factor, cancel, rewrite. And when you rewrite, make sure you write them on their proper position. Whatever is left on the numerator must be on the numerator. Whatever is left on the denominator must go on the denominator. So we did domain, we did multiplication. Now for division, it's same thing with one more extra step. Before you go factoring, we are going to do keep, change, flip. That's all is difference between multiplication and division. So let's do one. Oh, I had two. Pick one. Left or right? Left? No problem. So first step, keep, change, flip. That's the only difference between multiplication and division. In multiplication, you go factor indirectly. In division, yes, you can go factor directly, but then you have to do keep, change, flip. Or you can start by the extra step, keep, change, flip, and then you go do the multiplication. It's up to you. So I'll do keep, change, flip. Keep, change, flip means keep your first, the left fraction, but change your division sign into multiplication. So we don't know how to divide. Instead, we multiply by the reciprocal. So we are going to multiply by the reciprocal by flipping our second fraction. So x to the 4 minus 3x cubed goes in the numerator. X cubed plus 5x squared goes in the denominator. Just flip the second fraction, but leave your first fraction alone. And now it became a multiplication problem, which is factor, cancel, rewrite. The division has 4 steps, multiplication has 3 steps. So let's see how do you factor. X squared minus 25. GCF or difference of perfect squares? Perfect squares. So we get 2 factors from there. What 2 numbers we have? Plus 5, minus 5. The denominator has 3 terms, means 2 factors directly. Multiply to 6, combine to 1. Is it 3, 2 or 6, 1? Which one? 3, 2. So minus 3 plus 2. Oh, we have 2 terms, both on the numerator and denominator. So what do you do? The numerator. GCF or perfect square? GCF. Which one is our GCF? The 3 power or the 4th power? 3, smaller one. So when you factor out x cubed, what is left? And then minus 3. On the denominator, we have 3 power and 2 power. So which one? Square. What is left? and then plus 5. So you're done with keep, change, flip, factoring, and now you're going to do canceling. Start by the left, x plus 5. Do you see any x plus 5 anywhere on the denominator? Yes, so you can cancel them. Then we have x minus 5. Do you see any x minus 5 anywhere on the denominator? No. So we're going to keep this. Then we have x minus 3. Do you see any x minus 3 anywhere on the denominator? Yes. And then we're left with x cubed. Do you see any x with any power on the denominator? Here, right? We have x3 on the top. So x, and we have 2 of them on the bottom. So when you divide, how many left? Where on the top or on the bottom? On the top. So yes, we can cancel them, and we left with an x on the top. So we have x minus 5 on the top, and what is left on the denominator? X plus 2. So we rewrite them in the proper position. On the numerator, we have x and x minus 5. On the denominator, we have only x plus 2. You don't have to multiply, leave it alone. And you're done. And now you're ready for tomorrow's exam. I told you what will be in the exam. 1 division, 1 multiplication, 1 domain. That's it. And then from chapter 6, 8 factoring, 1 solving, and 1 real life application. And then the rest are exponent rules. 8 factoring, 1 solving, 1 application. Did I miss anything? 1 solving, 1 application, 8 factoring, chapter 6. And chapter 7, again, chapter 7, 1 domain, 1 multiplication, 1 division. So 3 questions from chapter 7, 8, 9, 10 questions from chapter 6, and the rest are exponents. Any question before you leave? Definitely don't be late. Come early. I will try to be early. I may not be able to because I always miss my bus, but I'll try my best. Huh? Oh, reflection, yeah. If you have a reflection from your case studies exam, please give them back.
EXAM3 is on the first page.
Huh?
The
You do shit?
I did better this time.
Yes, you did. I was impressed. If you don't have them today, make sure you have them by tomorrow.
So next one's gonna be like mix of lab tests and this one.
In tomorrow's exam?
Yeah. So
Yeah. Chapter 6 and 7. As long as you know you have to
this section 7.
and exponentials.
So how many questions do you find?
8, 9, 10. Why did they? So 8, 9, 10. 10 from chapter 6, 3 from chapter 7, to 13, and then the rest are exponent rules.
Or like the same one today.
Same one you did, and then the negative power thing, yeah, you did 1 question.
See you tomorrow.